Hello and welcome everyone. Thank you for joining us today for our webinar titled Getting Your Feet Wet with Machine Learning. My name is Patrick Moran. I'm on the marketing team here at H2O.ai. I'd love to start off by introducing our speaker. Megan Kurka is a customer data scientist at H2O.ai. And before I hand it over to Megan, I'd like to go over the following housekeeping items. Please feel free to send us your questions throughout the session via the questions tab in your console. We'll be happy to answer them towards the end of the webinar. And this webinar is being recorded. A copy of the webinar recording and slide deck will be made available after the presentation is over. And without further ado, I'd like to hand it over to Megan.
Hi, everybody. Thanks for joining the webinar today. I'm going to be discussing kind of an introduction to machine learning and a little bit about our products that we offer and how you can use them for machine learning. So let me start by going over the agenda, and then we'll dig into the content. So today we're going to be covering just kind of a high level what is machine learning, and then I'm going to do an overview of the products that we offer, and I'm going to focus in on two of our products, open source H2O-3 and Driverless AI with a demo. So that's what I'm going to be doing today. So we'll do a little intro, then some information about the products, and then the demos. I also wanted to just mention that we're going to have 45 minutes of the content, and then the last 15 minutes will be reserved for questions. So if you have any questions, you can type your questions into the questions tab on BrightTalk, and I'll answer them at the last 15 minutes. So I'm not going to pause for questions while we're talking in the beginning. Okay. So first, we're going to do a machine learning overview. So the idea with machine learning is that I want to learn something about data, and there's data everywhere. Any business can gather data, and the idea is, can we leverage what is called machine learning to learn something about our data? And the reason why we want to learn something about our data is because we can then maybe understand our customers better or predict what will happen in the future, recommend products to a certain group of customers or a particular customer, for example. So there's a lot of different things we can do once we understand our data, and machine learning is the idea of understanding our data in an automatic way. Now, for example, we'll take these really simple picture. I have different points. I have some round circles and I have blue squares. The idea with machine learning is it's going to see that there are this group that looks like blue squares and a group that looks like yellow dots, and it's going to learn to separate them. So that's what machine learning is going to do automatically. Now, I can take a look at this picture manually and see, okay, how could I draw a line to separate them the best? So I could do that myself, but machine learning is going to do that in an automatic way. And this is a really simple example. There's just two different shapes. But with data, you're going to have many, many different columns or features in your data set. So the data can get very complex, and it can also get very, very long, a lot of rows. So having someone manually review a data set is really time consuming and almost impossible. And machine learning acts as a way to either just give you general information about what your data looks like or help you predict something in the future. And that's the high level goal of machine learning. There are two different types of machine learning. The first I'm going to mention is called supervised learning. With supervised learning, it's this idea that I know what I want to look for. So let's take, for example, we have customer transactions, a data set of customer transactions, and we want to figure out how much a customer will spend. Well, we know how much a customer spent in the past. We have that in the transactional data. So I have the information at hand, and I want my model or my machine learning algorithm to find that. How much will a customer spend? So with supervised learning, it's very clear cut in the sense that I know exactly what I'm looking for. And the goal of the machine learning model in this case is to try to predict how much a customer will spend with the least amount of error. And there are different algorithms that do that. So we have linear models, random forests, gradient boosting machines, neural networks, and stacked ensembles in our products. But really, these are just different tools in order to find that same answer. And some have kind of advantages in some situations or disadvantages in others. We can think about supervised learning not just for picking a number, predicting a number, but also for predicting yes, no, or red, white, blue, so some kind of class or category. And that's called a classification problem. But it's the same general idea. We have a specific piece of information that we're looking for. In this case, we're looking for if a customer will churn or not. So thinking back at my transactional data, I know when a customer has bought something. Maybe I say that they churn if they haven't bought anything in 6 months. And from my data set, know in the past who's churned. So with machine learning, supervised learning, I'm asking it specifically to figure out who's going to churn, looking at the historical data, and it's going to use that to try to tell me who will churn in the future. So for supervised learning, it's very much, I'm looking at this historical data in the past, and I'm particularly looking at one column. And I'm going to let the machine learning algorithm figure it out, what patterns relate to that particular column. And then I'm going to use that in the future to help me tell me if a customer will spend a lot or if they're going to churn. And today we're going to be focusing on mostly supervised learning, but I'm going to also talk a little bit about unsupervised learning. So unsupervised learning is this idea where I don't particularly know what I'm looking for. So for example, I want to learn about my data. I want to know if there are similar groups of customers. That's unsupervised learning. So I don't know what the answer is. I don't know what the cluster should be. But I want to see if an algorithm can find, basically groups where they're naturally separated. Now, this is unlike the supervised learning where I had known in the past if a customer churned, or I knew in the past how much a customer spent. I don't know from my past data what the cluster should be. I'm asking the machine learning algorithm to just tell me what it finds about the data. So what are those natural clusters in my data? Likewise, there could be something like anomaly detection done with unsupervised learning. So historically, I don't necessarily know who's an anomaly or not, but I'm asking the machine learning model to tell me who does it think is an anomaly, who's been maybe behaving differently. So maybe some kind of fraudulent behavior, high value. When a data scientist does this machine learning approach, generally this is the kind of steps that they're doing, either for supervised or unsupervised. So there's first this step of data integration. So we were just talking that the machine learning algorithm's goal is to learn about the data. The first step is we need to gather that data. So maybe we have data in different sources. We're going to kind of group them together, merge them together into a single table. Then we're going to do some maybe data analysis, feature engineering. Essentially, we're going to look at our data and see how does it look? What's the general distributions of the columns? Is there any new columns that I want to add that I could think are helpful? So maybe, for example, predicting how much a customer would spend, maybe knowing the day of the week they bought is helpful. Maybe some people spend more on a weekday. So that's an example of adding a feature, something called feature engineering. So the data scientists will typically spend some time doing that. Then they'll build a model. This is where that machine learning algorithm comes into play. We're going to train a model on that data to either predict a specific column, which is supervised learning, or just to learn about our data, which would be something like clustering or anomaly detection. We finally get our model that we like. We'll learn about our model. How well did the model perform? When does it do bad? When does it do well? What's the model finding? So what is it generally telling us about our data? For example, our customers that spend on the weekend, our customers spending more on the weekends than on the weekday. And then finally, we're going to actually use this model in production. So we're going to try to deploy this model. So that's the general data science workflow. Now, today we're going to be showing how we can do that workflow with H2O. So I'm going to go over our products that we offer, and then we're gonna do a couple of demos with the same use case to show how we could use H2O products for machine learning. So here's our platform. We have the open source products on the left side. There are two products that we offer. One is H2O, H2O-3. It's our in-memory distributed machine learning platform. And we also have Sparkling Water, which is our integration of this open source H2O with Spark. I'm going to talk about these two first and do a demo, and then we're going to talk a little bit about Driverless AI. Driverless is our enterprise commercial software, and you'll see the differences in the demo, but it's much more automated. So if you think about the two major differences between the products, with the open source products, you have a lot of control as an end user. And with driverless AI, you have a lot of automation. But both of these products are doing similar things where we're building machine learning models on top of data sets to gather insights or learn how to predict something. So I'm going to start off with talking about H2O-3, which is our open source product. So very high level, what's H2O? H2O is an open source in-memory machine learning engine. All of the algorithms on the open source H2O are parallelized and distributed, so they're written in distributed Java. We have a bunch of different algorithms, and again, those are just different tools to build these machine learning models. But we have things like linear models, random forest, GBM, XGBoost, deep learning. And since they're written in distributed Java, they can scale. So one of the points about H2O is that it can handle big data. You can run H2O on your laptop, but you could also run it on top of Hadoop or Spark and allow it to leverage your full data set. And the last thing that I'm going to mention on this slide is that for H2O-3, you have Python and R clients. So if you're a data scientist who's familiar working with Python, for example, you can continue working with Python on your laptop and connect to the H2O-3 software and have it H2O-3 be running on your full data set while you're working in Python. So I'm going to show an example of that today, but just to quickly highlight that, well, let's say I have an H2O cluster. This is a distributed H2O in-memory cluster. So it's distributed over multiple servers. Me as an end user started an H2O cluster somewhere. I'm on my laptop, maybe in R or Python. And I stay in R and Python, but I'm basically using H2O library to tell this H2O cluster what to do with the REST API call. So the H2O cluster is across multiple JVMs, and I'm using R to talk to it. The benefit of that is that I can work with billions and billions of rows of data, but I can actually stay in R or Python where I'm familiar with it. I don't have to sample down my data to fit on my laptop or to fit onto one server. Okay. With sparkling water is our H2O integration with Spark. So why use sparkling water? Well, you can leverage a Spark cluster. So we're basically launching H2O-3's machine learning engine on top of your Spark cluster. And the reason why you might want to do that is because you can leverage Spark for their data munging functionality. So you can use Spark for the data munging piece, maybe merging data sets, adding new columns, and so on. And then you can use H2O-3 to build that machine learning model. And the last piece I want to mention is you can use sparkling water to leverage Spark pipelines. So it's really easy to incorporate an H2O-3 model into existing Spark pipelines. Makes it really quick then to productionize. If you are using the same Spark pipeline to create a model, you can use that same Spark pipeline to productionalize it. Sparkling water is similar to open source H2O, except we have a Spark cluster. And we're launching the H2O library on top of that. Both of them are distributed in memory. And this allows me to kind of, again, take advantage of Spark's data munging functionality. Okay. So with that introduction to our open source products, I was gonna turn it over to a demo. We're gonna build a model and we're gonna do it live with H2O-3 and take a look at how it looks. And then we're gonna talk more about driverless and do the same demo in driverless. Okay. So here you can see H2O Flow. It should say H2O Flow in the upper left corner. This is our web-based UI for open source H2O-3. Whether you use H2O-3 or sparkling water, you're both going to get this Flow UI. And this allows you to point and click through a machine learning workflow. But as I mentioned before, you can use also our Python or R APIs. So if you prefer to write code, you can do that. You don't have to use Flow, but we're going to use Flow today for part of it just to show it in the demo. Okay. So I'm going to start by importing some data. I have a training data set. I'm going to import it and parse these files. And we're going to take a look at the data. Now, with H2O-3, we've imported this data locally from my desktop. It's a smaller data set. But as I mentioned, it is written in distributed Java. So a lot of times we have our users importing data sets from HDFS or something, something like that. And that ingestion will be parallelized across the H2O cluster. So this handles very large data. I've imported my data set, and we're going to just take a look and view the data. So here we can see our data set. And if anyone's familiar, this is public data set on Airbnb. So we have some information about the Airbnb. It's just kind of a rental app for homes. So we have the name of the Airbnb. This one's called Clean and Quiet Apartment Home by the Park. The ID and name of the host. The neighborhood group. So we have 4 different neighborhood groups in this data set. And the exact neighborhood. So this is all for New York City area. Then we have the latitude and longitude of the location or of the Airbnb. Room type. So is it a private room, shared room, or the entire home or apartment? The price. Minimum nights. Number of reviews. The last review date. And then some other information. Today we're going to try to use open source H2O and then Driverless to build a model to predict price. So I'm going to go back up to our data set that we saw in Flow. And the first thing I can do is I can start looking at the different columns. So I'm going to click on room type. And here I can see the distribution of room type in my data set. So most of the people are listing an entire home or apartment. A little less than 50% are having a private room. So it's a private room within an apartment. And then only a small portion have a shared room. So that means a room shared with them. We're going to take a look at another column now. And we're going to look at price. So here's the distribution of price. Most of the price is close to 0. It's actually got an outlier out here with a really high value. So some Airbnb in this data set is going for $9,000, almost $10,000 a night. And now we're going to ask H2O-3 to build a model. So what I'm going to do is I'm going to go to Model, run AutoML, and we're going to build a model. And what AutoML does, it's a little bit different, is it's actually going to build a lot of models for me. So with H2O-3, I have the option to select a specific algorithm. And again, those are just the tools that we can use to build a model. So I can ask to build a random forest model or a gradient boosting machine or an XGBoost model. But I can also ask to run AutoML. And what AutoML is going to do is it's going to try all of these algorithms for me. And it's also going to do something called parameter tuning. So for example, if we build a random forest model, that's a bunch of decision trees. And one of the parameters that we can configure is how deep the decision tree goes. What AutoML is going to do is it's going to try different depths for us, for example, and see what parameters help improve the performance for this data set. We're going to basically end up building a bunch of different models, and it's going to tell me how well they did, which one got the price most correct. So I'm going to select my training frame. I'm going to select my response column. And that's really all I have to give it. It's going to try these algorithms that we offer. I'm just going to run it with all the defaults turned on. I'm going to build a model. You're going to see this AutoML build has started. You can click on View and Monitor Live. And we're actually going to see as models pop up that are being built. So right now it's building our XGBoost model. And as we see in the leaderboard, one XGBoost model has been built. It's now building a second one, if you can see up here. So this second one has maybe slightly different parameters. Once one model is built, we can take a look at it. So by clicking on this hyperlink, we can see more details. Here's our scoring history. So here's how the performance changed as the model added more trees to the XGBoost model. Here's the variable importance. So here's what's most important for this model. So in this case, minimum nights is the most important in predicting whether or not, what the price will be for this particular Airbnb. And then we can see other things. For example, it's automatically doing cross-validation for me, and I can see the cross-validation metrics. So here's the mean absolute error. So on average, this particular model was $72 off in the price prediction. And we'll look up again, and we'll see that it's built 4 so far. We have 3 XGBoost models and a GLM model, and they're ordered based on their performance. One thing I want to point out is now that this model has been built, I can pick the best one, and I can ask to download the model deployment package, which we call the Mojo, which is a model optimized Java object. This is just a Java object that can be used in production. It's completely independent of open source H2O-3. So this can be deployed really wherever you have a Java environment available. And this makes it very easy to productionize. We have a bunch of different design templates for the Mojo. And with examples, you can use this in a Spark pipeline. You could use this in a Hive UDF. You could use this with a REST API. So it's very, very flexible. And you'll get this output for every model that you build. Now, if I had wanted to do this same workflow in Python, I'm just going to go to my Jupyter notebook right now. We would do this by importing the H2O library and calling H2O.init. This is going to start the H2O cluster for me locally. That being said, I could also have a H2O cluster running on Hadoop or Spark and connect to it there. We can import the data. So we'll do H2O import file. You can see our data set in Python, so it'll look similar to a pandas data frame, and it will also behave similar to a pandas data frame, so we can actually do some data munging, similar how we would do it in pandas. We can ask to see the distribution. So we saw that distribution of price before. We can see it again in Python or in the Jupyter notebook. And then we can run AutoML. So this is what we had just done in Flow. Here I'm calling or initializing the H2O AutoML, and I'm saying I want it to run for only 5 minutes. I give it my training frame. I can also give it a leaderboard frame. So what do I want this model to be tested on? And you'll get a leaderboard out. And something to note, which we didn't touch on much, is it will try all the different algorithms, but we'll see that the best model is something called a stacked ensemble. So this is actually taking some of the models that were built in AutoML and combining them. And the idea there is that one model may be good, but having multiple models together may give a better result. So this is actually combining multiple models into one, and these 2 stacked ensemble models have the best performance. So lowest error in predicting price. We can also ask H2O to do some more introspection of this model. So we talked about the leaderboard and how we can get that model object. We can also get a partial dependency plot. So here I'm asking for the best AutoML model, and I'm asking H2O to tell me how does the room type affect the prediction. So as we talked about before, there are 3 room types: entire home, private room, or shared room. And here we see the average price if the particular apartment was entire home. So about over 200 in New York City. If it's a private room, the price drops down to $100, and if it's a shared room, it drops down even further. So this is really helpful because it gives you a little bit more insight into how the model makes the decisions that it does, and then you can use that to confirm with your business knowledge if it makes sense. So for me, it makes sense that the entire home or apartment will have the greatest price prediction. The last thing I want to note in our H2O-3 demo before moving on to driverless AI is that we do have something new available called AutoDoc. This is available for H2O-3 models. It's a enterprise commercial product with a Python API. So I've just imported this ML AutoDoc into Python. And all I do is ask it to create an AutoDoc. So I give it my H2O instance, my configuration, which I'm just saying basically where do I want this AutoDoc saved, and then what model do I want this automatic document built, and I render the AutoDoc. What will come out is a saved document in this location, which I'm going to pull up. Here we can see that same document, and you'll actually get an automatic document talking about that best model. So here's the sections available. We have an overview of the experiment. 15 original features were used. Here's information about my H2O cluster, information about my training data, my numeric columns, min, max, mean, my categorical columns. We have my feature importance information. Final model. And then some graphs around how the model performs. So here's some prediction statistics and partial dependence plots. So we showed a partial dependence plot in Python, but these will also be included in the AutoDoc. So here, for example, I can see how the price changes for the different neighborhood groups. And it will also include an out of range option. So here's what the price prediction would be on average if it was a new neighborhood group that had never been seen before. Here we can see that same partial dependence plot we saw before. Entire room has the highest prediction. Private room and shared room go down further. And just to note below that in the AutoDoc, you're going to see the frequency. So entire home or apartment is the most frequent as we saw before. Private room is then the second most, and then shared room. So this is helpful because you get a pretty good context of not only the average prediction for each category, but how frequent it was to see in the data set. So with that, I'm going to start talking about driverless AI. We're going to do the same exact demo we did here, but we're going to use driverless AI instead. All right, so we had talked about the data science workflow before. Together, we had done the modeling part in open source H2O-3, so I already had my data integrated, and I didn't really do any analysis or feature engineering. So we used AutoML to build that model over and over again, different algorithms, different parameters. And then we used partial dependence plots and that automatic document to understand and explain it. And the Mojo could be used to deploy it. What driverless AI does is adding that data analysis part and feature engineering part. And it's going to do all of this actually in an automated way. So we're going to see that together. But I'm just going to showcase really quickly the different pieces of that workflow. So you can drag and drop data inside driverless AI. We have a bunch of different data connectors. We also offer automatic visualization, automatic machine learning, which I'm going to show, model documentation and machine learning interpretability, and then the scoring pipeline. So it's similar to that Mojo we were talking about. So I'm going to go back and we'll start that demo of H2O-3. Okay. So I have my data sets here, same data set, my Airbnb data. If we take a look at the data set rows, we'll see the different data set, different information about the Airbnbs. What driverless AI is going to do is it's going to give me an option to predict. This is going to set it up for supervised learning. So I have a target column or a column I'm interested in predicting, price, and I can give it a test data set. This is the data set I want to see how well it performs on. And the idea with the test data set is I want to know how the model will do on a completely untamed data to make sure it will do well in real life. That's all I need to give it. We're going to launch the experiment. And driverless AI is going to start running. Now, this is going to be a little bit different than AutoML, as I mentioned, because it's going to do a lot more automation. One of the things that driverless AI is going to do that's unique to driverless AI is that it does something called automated feature engineering. What that's going to do is it's actually going to create new columns for my data set. So we had talked before, what if we're trying to predict how much a customer will spend? Maybe just taking the date and adding if it's a weekend or not could be helpful. So there's these quick and easy columns we can add from our existing data to help a model, a machine learning algorithm learn. Driverless AI is going to do this process automatically. Typically, machine learning algorithms have a hard time understanding text data and categorical data. It does pretty well with all numbers, but in real life, most of the time we'll have some categorical data, we'll have some text data. Even looking at our particular data set today with Airbnb, we have some categorical data like the neighborhood, the room type. And we also have some text data. We had that name. So someone was saying they had a private apartment, maybe near the park. So that's text data. We want the model or the algorithm to understand that text because it could be helpful in predicting the price. If we don't do any feature engineering, it's pretty hard for the algorithm to take to get insights into the text and sometimes categoricals as well. So what Driverless AI is doing right now is it's building a series of different models, and we'll see those models on the left-hand side. Each yellow dot is its own model. So it's building all of these different models. It's trying different algorithms, different parameters for those algorithms, like AutoML, but it's also trying different features. So you may notice that in this middle screen, this list keeps updating. This is the most important variables for the current best model. I'm going to zoom into this. So we'll see that some of the columns are similar. We have that availability of number of days available, minimum nights, the longitude. Those are the same, but a lot of them have been modified. So here, for example, is this column called CVTE room type. What this is actually doing is it's taking the room type and calculating the proportion or the average price per room type. And it's doing that in a way to prevent data leakage by using cross-validation. So essentially, we have under the hood smart ways of converting this categorical data or this text data into numbers. And we'll see that it just updated again. So now the most important feature is how frequent the room type is. So how many times in the data set did we see the private room, the shared room, or the entire apartment? So this keeps updating as the model learns more about how to predict price. Below that, we'll see this other new feature called TXT name. What this is doing is it's actually taking that name, so that description of the Airbnb, and it's using machine learning to transform it from a string to numbers. In this case, it's using something called TF-IDF, or term frequency, inverse document frequency, to convert the text into a numeric vector. So now we've taken name and we're representing it as numbers to help the model learn. With the open source H2O-3, since we didn't do any pre-processing or manual feature engineering, it actually didn't really use name at all. So we missed out on a pretty important variable. We can see that it's coming up in the top 10, this name variables. Driverless AI is going to run, and it's going to keep trying to improve this model, and its only goal is to reduce the error in predicting price. So it doesn't have any specific information about Airbnbs, nothing like that. Its only goal is to get a better model. And what this means is that it's pretty flexible. So we're doing an Airbnb demo today, but it does not related to Airbnbs at all. We could do a model to predict if a customer will churn, for example. We could build a model to predict how much rain there'll be next month. It's very flexible. We just need to make sure that we give it data which might have some insight. And Driverless AI is going to keep basically doing this process as data scientists will do, but it will do it in an automated way. So me as a data scientist may take a look at a data, build a model, see how it does, what kind of features could I have added that might help. Driverless AI is doing this, but it's doing it very quickly and automatically for me. So it's already built all of these different models, all these yellow points, and it's tried all of these different variables. It's even trying clustering. So as we talked about in our slides, there's unsupervised learning. It's doing that unsupervised learning approach is just learning about our data set. So what kind of natural clusters are there of Airbnbs? And it's using that cluster information to see if it can help when building a model to predict price. Once the model has been built, this one's already complete, it's the same model. We'll see information about what happened. So if we go on our upper right-hand lower side, we'll see it ended up actually creating 491 features from our original data set, which I think had less than 20. And it selected 118 of them. So 118 of them were important. And it also built a lot of models. So it built 30 models in the beginning, followed by 10, followed by 15. We'll see here how well the model did on our test data. So we'll get some summary down here. Once the experiment is completed, you'll have a couple of different options. You'll be able to interpret the model, which I'll show in a minute. You'll be able to download the predictions. So we had some data here. Maybe we'll want to know what the predictions were for my training data set or my test set. So what did the model think the price was? You can also download the Python scoring pipeline or the Mojo scoring pipeline. So what we had mentioned earlier in H2O3, that Mojo, it's very similar in Driverless AI. It's this Java object that's completely independent of Driverless AI. However, with Driverless AI, we did all this automated feature engineering. So the Mojo not only knows how to score with the final model, but it knows how to make all of these new columns as well. So it can take a raw record of my Airbnb data and do this text preprocessing or this target encoding, and then have it run through that model and give me a prediction of price. We can also ask for it to visualize our scoring pipeline, which is going to showcase what did that final model look like. We had our features, and it ends up building two light GBM models, two 5-fold light GBM models here that all went into a stacked ensemble. So it's combining all of those models together, and the output is the price prediction. And if we click on a particular light GBM model, we can get more information about what happened here. So if we zoom in, we'll see all of the features, how they were transformed or engineered going into the light GBM model. So we can see that it does get very complex compared to our open source H2O3 model because it's doing all this automated feature engineering and then stacking those models together. We can download our automatic document. I'm going to pull that up right now. This automatic document is going to have more sections because it did quite a few more steps than AutoML. It's doing the automated feature engineering, cross-validation, and parameter tuning and stacked ensemble of the final model. And we can see similar things. So we have our training data information. We have our experiment pipeline. So these are the steps that have followed. These are the features that were created and how many were kept. What is the final model made of? And then if we go down a little bit further, we'll have the feature transformations that were used. So here's all the features that were used in this model with a description. And most of them are not the original. So most of the times, automatic features were more helpful than the original features. And if we go down a little bit further, we'll get the performance of the final model. So here's my mean absolute error. On average, we are about $49 off in our price prediction. Just as a comparison, in our open source H2O, we were about $61 off. Now, this isn't to say that open source H2O or Driverless AI, one of them are better. It's just to say that the feature engineering is a really important step. Since Driverless AI automatically did the feature engineering, we can see the benefit here, that it reduced the error by about $10. In H2O3, we could also do similar feature engineering. It would just have to be done by the data scientists in a more manual approach. The data scientists would explicitly have to ask to do target encoding or some text preprocessing. It's definitely possible, and it does improve the performance quite a bit, which we see here. Here's our actual versus predicted prices. And then if we go down a little bit further, we'll see those partial dependence plots again. So similar to what we saw in our previous H2O3 demo, you can see how the different variables affect the predictions. These automatic documents come out of the box with Driverless AI. Once the experiment is complete, you just need to download the auto report. Now, the first button I had mentioned was interpret this model. I'm going to click on interpret this model now. And this is going to take us to our model interpretability module. This is able to tell us basically how did the model make the decisions that it did. We go to our Driverless AI model tab. You can see feature importance. So we see the features that were the most important. However, these are almost all automatically generated by Driverless AI. So we can also ask Driverless to show us what were the most important features along the original data set. So if we looked only at the original features, kind of transformed it back to our original, the most important features would be name and then room type and then neighborhood. We offer something called Shapley here. Shapley is something like reason code. So how did each variable affect the prediction? If I ask for a specific record of my data, I'll see how the prediction was affected by each feature. So the gray bar you'll see here is how did this particular value affect the price prediction? So in this case, the neighborhood that this record was in reduced the price by some amount. The availability increased the price. So this is going to give us a little bit more understanding at a local level for each particular Airbnb. How did the prediction, how was the prediction generated? And then we also had the partial dependence plots that we saw before in driverless AI, in H2O-3. On average, if it's an entire room or apartment, the prediction is about 186, and that drops down to close to $100 if it's a private room, and then drops down even further. You can see the different variables here. Which particular neighborhood groups had the highest highest price. So Manhattan had the highest price prediction, followed by Chelsea and the West Village. So again, we can use these graphs to make sure that the models match what we were expecting to see. We also offer something called disparate impact analysis. This will essentially allow you to see how different particular categorical variables affect the prediction. And we offer sensitivity analysis. So here I can use this particular module to see how if I change something about the records, maybe if I change the name or the room type or how many days it was available, how would it change the price prediction? And here's a full dashboard of what we offer as well here, so you can see it. And this is really helpful, again, just to understand the model. Maybe possibly find new insights. So is there something we're finding that we didn't know about, or does something look interesting, strange, matches our expectations or not, and so on. So with that, I'm going to spend the last 2 minutes quickly showing Q, which is one of our new products. Now Q is able to kind of gather automatic insights, and I would kind of talk about insights almost as unsupervised learning. So with Q, I've asked Q to generate insights for me on the same Airbnb data, and it comes up with all of this automatic insights for me. A little bit more about Q. It's written purely in Python, and the benefit of that is it allows me to, or any data scientist, to create apps. So something like an app store. I can make an app that maybe clusters, maybe analyzes my predictions, tells me if a lead is going to convert to a sale or not. Really, the sky's the limit. It's very easy to create apps. One of the apps that we offer is this app called Insight. And I've asked Q to make some insights for me. And just quickly, before the end of our talking section, I'm going to showcase some of the different availability or the different features it has. So it shows me the different distributions for different variables. Frequency. Williamsburg is the most frequent Airbnb location. And if we go down further, we'll see the correlations. What variables are correlated with each other, red being correlated, blue being negatively correlated. Reviews per month. All these different features and insights were gathered. I'm just going to drop down to the bottom so I can show some more information. We had that name column, and that was telling me the description of the Airbnb. So here we have a word cloud showing me the most popular words in this name. Insights in Q is also going to give me keywords and phrases. So these are the keywords, groups of 2 and groups of 3. Near Central Park, cozy private room, home away from home, New York City. We also can use it to generate some more text insight topics. So here it used LDA to find topics in my particular data set. And I can go over the topics in this UI. So topic 1 has things like cozy location room. Topic 2 has beautiful Brooklyn, amazing. bedroom apartment spacious, park near luxury, new Bushwick. So we can actually use this to go through the particular topics that were found in my data set. And the last thing I'll showcase in Q is it has also a graph of the word embeddings. So here we have used word embeddings, or a text preprocessing tool, to showcase which words were found to be similar. So Little Italy, similar. Empire State, gym and doorman are similar. All the airports are coming up next to each other. So here you can kind of gather an idea of what's similar in the text data set as well. Now the difference between Q in this particular example, or this Q Insights app, and what we were doing in Driverless and H2O-3 is that we're not looking at for a particular price prediction. We're just looking in the Q Insights to learn more about our data set. And that's a really nice starting point when we have a new model, just to learn more about our data set and see what it has to say about it. Now with that, I'm going to stop the presentations and I'm going to go over the questions. All right, so the first question is, what other companies are your competitors? How is your AI different or better than others? I would say we don't really have competitors per se. Open source H2O-3 and sparkling water are open source. And we really do work well with a lot of the other machine learning software available. How is your AI different or better than others? Again, I don't know if we're better or worse than others. We work really well hand in hand with a lot of other machine learning software platforms. But just to mention, with Driverless AI, we're able to handle all of the different data elements that naturally come up in data sets. So we can handle text, categorical, we'll do time series, and so on. We'll also provide an automatic document, model interpretability, and the ability to productionize your model. Okay, what other, is it possible to use convolutional neural nets? Yes, we do have convolutional neural nets in Driverless AI. We actually use convolutional neural nets to do text preprocessing. So we'll build a one-dimensional CNN model as a way to create word embeddings for a text column. So that's used under the hood. This is a good question. Right now, it's only available in Python, but it's still new. So definitely would love to hear any feedback. Okay, I believe that the presenter mentioned that automatic feature engineering was an aspect unique to H2O Driverless. Okay, thanks. So this is a really good question. So with automatic feature engineering, H2O has the ability to do feature engineering as well, but it doesn't do it in an automatic way. So let's pull up an example. I have my H2O tutorial, best practices. Let's do feature engineering. So I have a whole notebook here for feature engineering, just to kind of showcase the difference I'm talking about. So while feature engineering is possible in H2O-3, it's not automated. And this is what I mean specifically. Just gonna let it load. H2O-3 is going to require you to kind of tell it what to do. So I have a data set with some categorical, some text you're seeing here. The first thing I might do is ask H2O-3 to handle that text. To do that, I have to kind of tell it what to do. So I can use H2O-3 to do this, but I need to say explicitly what I want to do. The first thing I have to do is tokenize my words, my text into words. So I'm telling it how to tokenize, which words to remove. I have to build a word-to-vec model, which will convert that text to a numeric vector. And then I have to add that word-to-vec, or kind of transform my text into the word embeddings using my word-to-vec model and add it back to my data set. So again, it's not impossible. We have a lot of examples, but we saw that that wasn't automated. I had to go and write how to tokenize, train a word-to-vec model, use that word-to-vec model to transform my data, and then combine it to my original frame. So both products do feature engineering. Driverless AI does that automatically. Hope I answered that question. does your actual data structure need to be identical to your training data structure? That's a really good question. You don't have to have it identical, but if you don't have columns that you use in your training data, then your model is not going to be doing as well when you actually use it. So, for example, if in our Airbnb use case we used the room type, and that was really important. If we don't know the room type when we actually use this in production, our model is going to do very poor because it doesn't know the room type, so it's just going to mark that as missing and predict, and it's missing this really important feature. What I would really recommend is whenever you build a model, think about what data do you actually have in production. Not what data do you have right now, but what will you actually have when you want to use this model. If you work with what you have, you may have a lot of things you don't actually have when you use this model. You're not going to actually know yet, and the model will become much worse when you actually do use it. Okay. We are adding the ability for image handling and document handling. That being said, I think with documents, we have something called Bring Your Own Recipe in Driverless AI. What that does is it allows you to do some custom either transformation or feature engineering, custom model, or custom processing to your data. For a document, you could probably take that Word document and parse it as a text in a recipe and then build a driverless AI model on top of it. This one, Azure Blob Storage, I am not sure of that answer. I would have to check. What specifically does variable importance mean? Great question. Variable importance is how important the variable was in a model. And that importance definition depends on the model that was built. So with a decision tree, for example, the way we calculate variable importance is we say how much error was reduced if we split the data with it by this column. So if you think of a decision tree, it's going to split your data. Maybe if we do room type again, everybody that's a shared room goes to the left, everyone else goes to the right. When we did that, how much did it reduce the error? If it reduced it a lot, it's going to have a higher variable importance. When you think about a linear model, the coefficient is a variable importance. With something more complex like a nonlinear model like decision trees, typically that's how you'll do it. How much did using the variable reduce the error? And typically, the partial dependence plot should match that. So if you look at your partial dependence plots, you'll see that the variables that are marked as most important will have partial dependence plots that have the greatest change in the plot. So it's not flat. Okay. This is a question for AutoML. What max runtime secs does? What that's going to do is it's going to tell AutoML how long it's allowed to run. So if you wanted this to run only for an hour, you could set that number of seconds to an hour. So this just makes it so that it's not going to run it indefinitely if you don't want it to. You don't have to use the maximum runtime seconds. You could instead ask AutoML to run until it sees that the top model isn't getting better, so it's converged. But we offer a couple of different ways to tell AutoML to stop. This, I believe, is possible. We can share the documentation on how to productionize, and we have a couple of different options. How to get to the localhost instance with the H2O Flow? Oh, okay. So if you want to do that, we'll just go to our H2O. You're going to go to Download, H2O Open Source. You can click on Latest Stable Release. Here's the different ways you can do it. So to get to just Flow, if you just want to use Flow, you can just download H2O and you'd run this command in your terminal. If you want to use R or Python, we have information on how to install. With Python or R, you're just going to do this h2o.init command. And that's going to start H2O. Even if I started in Python, I can still access Flow. You'll see this URL. Click on that, and you'll get taken to Flow. So you can start it a couple of different ways, but they're all available on our website, all that information. Driverless AI has recipes to extend models and scores. This, I would say we don't have with H2O3, H2O3 itself has the ability, it's almost like bringing your own recipe for feature engineering. What I was just showing before with that, the handling the text data with Word2Vec, that's possible in H2O3. The ability to extend the AutoML with models and scores like a recipe, I don't believe we have that. I mean, I think it might be an interesting thing to discuss with our team. But right now, the algorithms that are offered are all the distributed Java algorithms. So that XGBoost, GLM, gradient boosting machine, so that they can scale on Spark or Hadoop, and they do output the Mojo. And that's why we have kind of those options, just because you're able to run that in a scalable way, and you will get the Mojo out. Difference between driverless AI and H2O3. Driverless AI is more automated, so you'll get I told you I didn't know that one. So you'll get the feature engineering, you'll automatically get that documentation we were showing, the model interpretability, the deployment aspects will be there. H2O3, it's scalable. That's one difference between driverless AI and H2O3. It's distributed. And it's a little bit more manual, a little bit more control. So it doesn't do all the processes automatically. AutoML compared to driverless AI. AutoML does the parameter tuning and does algorithm selection similar to driverless AI, but driverless AI does the feature engineering step too. And the Mojo that's outputted in driverless AI contains that feature engineering as well as the model. So it's kind of all in one, doing everything for you automatically and giving you the scoring pipeline with it. In the demo, I imported data from my local machine. You can, however, import from where you can run H2O wherever you'd like. So you can run on a separate server or cluster, and you can import the data locally from that cluster. You can upload the data from your computer to the H2O cluster, or you can import from something like HDFS or S3. I don't know where I went. How did the two products deal with overfitting? Both of them do automatic, so AutoML and driverless AI do cross-validation automatically. And the idea there is that it's going to build a model on some set of data and then see how it does on an external set of data. So the idea is that it never really looks at how well it's doing on the training data. It's always looking at how well it does on a new set of data. Mojo for production? Sure. So we have our documents page here. For H2O3, you'll see in our user guide, productionizing H2O, which is going to have all the information about how to use the Mojo. And you'll see a similar page in driverless AI.
All right, Megan, I think that is all the time we have for questions. Is there one or more, two things that you want to cover last, or do you think this is a good place to end here?
I think it's a good place to end. Maybe the last question, can we get the Python script of the PowerPoint presentation? I guess I'll let Patrick answer that. Yeah, definitely. So we're going to have the presentation slides available in a few hours here, as well as the recording itself of the session. So just be sure to come back to the same link that you did, that you used to access today's presentation. So just want to thank Megan for taking the time today and doing a great presentation. I want to thank everyone who joined us as well, all these great questions. The presentation slides, again, will be made available, and so will the recording in a couple hours here. So we hope you have a great rest of your day.